Hello students, let's discuss the question. In this question we are given that show that each of the relation are in a set A which is x belongs to z such that x is greater than equals to 0 and less than equals to 12 given by the first question is given. Firstly basically we are given the set that is x comma x belongs to z such that x is greater than and equals to 0 and less than and equals to 12. Here z is representing the integer. We are considering about the part 1. Relation is that r such that a comma b such that mod of a minus b is multiple of 4. So this is the first we are given here. Here we are given that we are considering about the set A where x belongs to integers and the value of x is from 0 to 12. So the set A from here is equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So this is our set A. We are given that relation is on a minus b is a multiple of 4. So from here the set is from 0 to 12 and the multiple of 4s here are 0, 4, 8 and 12. So these are the 4 multiple of 12. So basically if the difference between two numbers is either 0, 4, 8 and 12, then we can say that this is satisfying the relation. So here we are considering about the reflexive condition and the condition is that a comma a belongs to r. So basically, let's say a comma a belongs to r. So the relation is that mod of a minus b, that is a is a and a we are considering here. So mod of a minus a, when a is subtracted from a is 0. So mod of 0 is equals to 0. As we just discussed, the multiple of 4 are 0, 4, 8 and 12. So 0 is a multiple of 4. So we can say that the relation is reflexive. So this relation is reflexive for a comma a belongs to R. Now we are considering about the condition of symmetric. The condition of the symmetric is that if a comma b belongs to R, then b comma a also belongs to R. So let's say the relation is that a minus b, mod of a minus b. So let's say mod of a minus b is a multiple of 4. So mod of a minus b and the another is b minus a. So mod of a minus b is also equals to mod of b minus a, because let's say a is any number. If we subtracted a from b, let's say we get a positive value, and uh, if we subtracted b from here a, let's say we get the any numerical value which is in plus, and when we subtracted a from b we get the same numerical value as we get when we subtracted b from here, but it is in negative. But the relation here is modulus, and we know that the negative is not significant in the modulus relation. So we can say that a minus b is equals to b minus a, or we can say that if a minus b is a multiple of 4, then we can say that b minus a is also multiple of 4. So we can say that therefore a comma b belongs to R and b comma a belongs to R. So this is a symmetric relation. So this relation is symmetric. Now we are considering about the transitive. The condition for the transitive is that if a comma b belongs to R and b comma c belongs to R, then a comma c also belongs to R. So here let's say if a mod of a minus b is multiple of 4, which means that a minus b is also multiple of 4. In the same way, if mod of b minus c is multiple of 4, then b minus c is also the multiple of 4. We know that the sum of multiple of 4 is also equals to the multiple of 4. So the sum of a minus c, sorry, it's a minus b and b minus c is also the multiple of 4. So b to b cancel, we are only left with a minus c. So we can say that a minus c is multiple of 4. If a minus c is multiple of 4, so the mode of a minus c is also multiple of 4. So we can say that A comma B belongs to R, B comma C belongs to R, then A comma C also belongs to R. So this is a transitive relation. So this is the answer to the part 1. Now we also need to find the set of elements related to 1. Basically we are having the set which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So this is our set. The relation is that it is a multiple of 4. Let's say this is A, this is B, this is mod of A minus B, or this is condition whether it is multiple or not. If the value of A is 1, B is 1, so A minus B, mod of A minus B is 0 and it 0 is a multiple of 4. Let's say A is 1, B is 2, 1 minus 2 is 1, mod is here, so it's plus 1, but it is not a multiple of 2. Now A is 1, this is 3, so 1 minus 3 is minus 2, mod of minus 2 is plus 2, it is again not multiple. This is 1, this is 4, 1 minus 4 is minus 3, mod of minus 3 is plus 3, again this is not multiple. This is 1, this is 5, mod of 1 minus 5 is 4 and 4 is a multiple, so yes, it is a multiple. Now if we are considering about 1 minus 9, 1 and 9, 1 minus 9 is 8 and it is multiple, and the number in between are not multiple. So we can say that the elements which is 1, 5 and 9 are related. So this is the answer to the part 1. Now we are considering about the part 2. So in this part we are given the relation that is R is equals to such that A comma B, A comma B such that A is equals to B. So we are checking about the reflexive. So reflexive is if A comma A belongs to R, then we can say that the set is reflexive. So we know that A is always equals to A. So therefore we can say that A comma A belongs to R. So we can say that this is a reflexive function. This is a reflexive function. Next is we are considering about the symmetric function. We are considering if A comma B belongs to R, then B comma A also belongs to R. So from here, let's say if A is equals to B, if A is equals to B, let's say 2 is equals to 2, then B is equals to A, that is 2 is equals to 2. So we can say that B is also equals to A. B is also equals to A. So therefore we can say that if A comma B belongs to R and B comma A also belongs to R. So we can say that this is the symmetric relation. Now next is the transitive. For transitive we are considering, let's say if A comma B belongs to R, B comma C belongs to R, then A comma C also belongs to R. Let's say A is equals to B and B is equals to C. A is equals to B and B is equals to C, then it is clearly visible that A is equals to C. Then we can say that this function is transitive. So this function is also transitive. Now we need to find the set of elements related to 1. So here we are having the relation that is A comma B such that A is equals to B. So all elements related to 1 means all element is equals to 1. So if A is equals to 1, then B is also equals to 1, then A is equals to 1, B is equals to 1. So we can say that the set of elements related to 1 is also 1. So this is the answer to given question. So students, in order to solve this problem, we use the basic concept of relations and functions. I hope you understood the concept well. Thank you.
Don't forget to like and subscribe.